So on this video I'm going to be questioning the status quo, and therefore I should be questioned myself on this video as to whether this is actual factual or not. I'm just going to dive into something just because I want to explore possibilities and just see where we come. Okay, so this is land mass, okay? We take this like the UK, United States, Russia, China, all the land masses, yes? I obviously haven't drew these all in correctly because it doesn't need to for this video. This is your skim of salt water. And this is the core, and this is rocks and different medium. Okay, and in this video I'm going to be looking at, you know that when you have the, I can't remember what it's called now, the tectonic plates where one falls under the other, under the ocean. Usually triggers, when it gets caught on a ridge, it usually triggers massive earthquakes under the ocean and then triggers tsunamis and stuff like that, yes? But in this process where the land mass is falling down under the ocean, is it not possible that water, salt water, is trapped and going down there into the core with it? Because as you know, that it would come down and it would remelt into the core and then chuck out as a volcano elsewhere. That's due largely to the moon and also the sun, yes? Basically what that does is it takes the core, and if you think of a teaspoon and you bend it back and forth, before it breaks, it becomes very, very hot. Yes, very hot. So that's like the core, but the core, because it's spheroid, which is an oblate spheroid, I don't think it's actually completely circle, and I should never draw the Earth like this because technically the poles are squashed and the circumference is more let's say elongated due to this pull of the moon and pull of the sun. Yes? But because it is rotating and the moon is also slightly rotating on its axis and the star, this causes the core to become more this way, more this way. Another thing is that when we've got the axis, yes, and we have summer and the planet turns, this also changes the position of where the moon and the sun pull, and is it not possible that the core could move further down to cause the summer in Australia? You see, I believe in two things, right? And these two things is that we get heat from our star, but we also get heat from our core. Although very minimal, but still both need to be added into the equation because logically the planet can't get that cold as much as it is in space if it has a hot core. Okay, so this moon pulling on and the star pulling on the core is stretching it, and then because it rotates and the Earth is got pits in it, caverns, so there's more influence. The moon is also potted, so it's not perfectly round, let's say, because it's got dips here and then it sticks out more here. Yes?
Yes.
And as that rotates, if it's more bulging on the moon this way because of, let's say, a peak, or it's more dipped because of a valley, this alters how much of a pull you get. If it was perfect, if they were perfectly smoothed, you know, really smooth, stay there. If it was perfectly smooth, you're not going to get much of a influence. But because it's more bulged one way and more flatter the other, and the Earth is in the same, it also causes it to have more of an effect on the crust. Yes, this pulling. And so does the sun, let's say. It's probably more better that way. And plus we wobble, and we are back and forth from the star, back and forth. We wobble as well. Our star wobbles, and I think we follow its transition. All of the other planets, it gets more complicated, also have an effect on this squeezing. You know, because sometimes Mars is more closer in the sky, let's say we see it and then it moves away and its transition is slightly different to the Earth. We are wobbling too, as much as the stars are wobbling. If you've ever looked through a telescope, you'll see this. It's not just the stars that are moving, we are moving too. This all influences the core. Therefore, the metal inside is then being squeezed, pulled this way. Now it's being pulled this way. Now it's going back this way. Now it's going this way. Much like you're bending the spoon, therefore it's getting hot. That's what keeps the core going in its hot temperature, 101, let's say. So we understand that. And I think that when the core is here, when we move our axis or we go up and down, this slightly, our core is doing this, let's say. So, you know, it's not perfectly in the middle all of the time. Why is that relevant? Well, we'll get onto that. Now, we look at another one I want to quickly touch upon is the land mass. You know, we are seeing a lot of floods in these days. The last time we saw floods like this was in the Mesolithic period when we came out of the Ice Age. And I think we haven't seen many floods like that. There's a reason for it, right? The star is whether you like to accept this or not, the star is zitting out very tiny, but over millions of years, okay, this has an effect. The star is letting out little photons, yes?
Yes.
Trees, yes, are absorbing these photons and taking energy from deep within from their roots, yes?
Yeah.
And they are combining this energy. Therefore, in the nano spectrum, so we think of weight and heaviness is measured by me standing on some scales. But I believe that if there was sensitive weighing material or scales that we had that could do nano, if I got a suntan, my skin has absorbed particles from the star. Therefore, on the nano spectrum, it has made me slightly heavier. It sounds really bizarre, right? But you are taking this stuff that usually, if it hits the atmosphere, most of it bounces off. Yes, and light scatter, and if it scatters this way because we've got an atmosphere, yes, and most of it is bouncing off. So we're not absorbing all of that. But when you've got such mediums such as human flesh, animals, and trees that take this, they are adding material to the planet, although very little, but over a larger amount of time, such as millennia, this is adding more and more of a bulk to the planet. Then when trees rise up and die, rise up and die, rise up and die, over millions of years, where a tree grows, pulls its nutrients, combining this stuff from the star, although very minimal, over a longer period of time, this is adding volume to the planet. Although very slowly and insignificant over the short time, but over the longer term, that is more weight being generated and gathered for the planet. Then when these trees die, they are building up layers of mud. That's why when we dig down to the Mesolithic period, we can pull out massive per meters worth of soil. Soil is not naturally found in the solar system anywhere. It's a byproduct of nature. It's decay from the leaves, it's decay from the wood. This is not naturally found. So the more mud layers that you have when you go down and further down and further down, eventually, before, let's say, we can't tell because we've got this, refreshing of our crust. Yes, so when it goes back down and remelts and then spits out as volcano, we've got this regeneration. So, but if we didn't have that and we were able to dig down further enough, yes, we would then hit a rock layer or a layer and it would then tell us how old nature, therefore we could back to find out how old life is. But we can't because it's recycling in this process that we have. However, trees decay far more quicker than this melting of the, let's say, the crust that goes in to be regenerated. And this decay and dying of the trees is creating landmass. And that's why there's so much soil and it's bulking and getting taller and taller and taller and taller. And after a while, you then you start to outrun the sea. And it gets bigger and bigger and bigger and bigger. And when we cut down our forests, we stop this process of building. And we didn't notice it straight away. Now that is because this is over a long period of time. And now we're starting to see it with floods. Yeah. Because we've stopped it. We've cut down the trees and we've put concrete across it. And now this concrete is basically what we call static. Whereas a forest isn't static. It's constantly falling and new is rising within this and it's lifting and lifting. That's why trees grow tall away from the earth. So that when they die, they drop their seeds above this, let's say this soil progression process that's happening. And then when we cut down the trees and we put concrete there, there is nothing, and we would have to keep layering the concrete over it, although very small. Like a road, much like a road. We'd have to do it a lot faster than we're doing, which practically seems impossible. And then if we cut away different stuff and different things like that, we lose this rising up. Therefore, water will pool over these areas, perhaps because of this. And soil is very absorbent. It allows this water to transition down because the trees are drawing from it. So the more they draw. Anyway, so moving on from that. That's one thing that I